Hi everyone. In this last video, we are going to look at Boxplots, which will also allow us to have a formula for figuring out outliers. So I'm going to start with a little bit of an introduction for why Boxplots are important. So right here, I've got a snippet of a data set and a histogram that shows the percent change in population for all 50 states. And this is based on the census figures for the year 2000 and the year 2010. So I couldn't show all 50 states in the data set, but I wanted you to see what it looks like. So I've got three variables. I have the state, which is the identifier variable. I have the percent change, which is a quantitative variable, a continuous quantitative variable, and then the region, which is a nominal qualitative variable. So the histogram on the right shows the percent change for all 50 states. And when we look at this histogram, we would like to describe the distribution. So we've got a unimodal distribution. It looks like it's skewed right, and this could definitely be an outlier. Because of this outlier or possible outlier in the skewness, we would say that the median is the best measure for the center and the IQR is the best measure for the spread. Let's see what happens when we split up this data and we look at two separate histograms where we compare the region. So if we look at the percent change for the Northeast Midwest region and compare that with the South and West regions. So now I've got two separate histograms. And again, I can describe their shapes. But if I want to compare them, it's actually rather difficult when looking at these histograms. If you'll notice, the axes are different. So looking at the bottom here, when you see the width of the bins, that's what I'm used to calling them. I forget what they're called in this new textbook. But when you look at the width of each of these bars, in this first region, the Northeast Midwest region, that width is 2.5, right? Because there's two of them between 0 and 5. But when you look at the South and West regions, the bin width is 5 because we've got two of them from 0 to 10. So this is 2.5 and this is 5. And then you can also see on the other axes, this goes up to 9 and this goes up to 7. So our axes are different, which makes it really hard to compare these distributions when looking at a histogram. And again, I can describe them, but I can't really compare them. So what if we looked at the two histograms in a back-to-back stem and leaf diagram? Well, this allows us to at least put it on the same set of axes, right? Because I have the, if you wanted to read this here, like let's look at this row here, then with the group of Southwest states, the data values are 1, 4, and 5 with a 0 in front. And the Northeast Midwest are 0, 2, 2, 3, 3, 3, 3, 3, 4, 4. If we look at, say, this row here for the Southwest group, the data values are 15, 17, 18, 18, and 19. And the Northeast Midwest group is just 15. So this does put on the same set of axes, and we can kind of tilt our screen here and see that we have that same unimodal distribution. It looks like we have an outlier over here. And on this one, we also have a unimodal distribution. And we can at least see that with the Northeast Midwest states, there's not as much spread as with the South West states. So we can at least compare these distributions a little bit better in this back-to-back stem and leaf diagram, but it's still really hard to look at this way. So now let's look at it as box plots. And I know I have not introduced anything about box plots yet, but I'm going to get into all of the technicalities of these in a second. but I want you to see is that the box plot allows us to look very quickly at both distributions. So this line in the middle of the box, that's the median of the data set. So I can immediately see that the median for the Southwest group is a lot higher than the median for the Northeast Midwest group. And the median would be my best measure for the center, since we could see from the previous distributions that we knew it was skewed. And now from here, the box plot gives us exact measurements for outliers. So this Southwest has an outlier up here, and then we have two outliers here. These we couldn't see in the histograms. We didn't even notice that this group had outliers, but the box plot allows us to calculate them. We can also see that the Southwest group is definitely more spread out than this Northeast Midwest group, which means that there's been a larger amount, it's been more spread out, there's more deviation in the percent change of population in that Southwest group. So we want to be able to create box plots. And box plots are created using quartiles. So again, remember that we have the first quartile, which is the 25th percent, the median, which is the 50th percentile, the third quartile, which is the 75th percentile. And what this does is creates for us 4 sections in our box plot. And we use the 5-number summary to separate these 4 sections. So again, you want to think about a dollar bill and quarters, right? We've got a 0, quarter, half, 75, the full dollar. So this 5-number summary separates our data into 4 quarters. And again, we can find that 5-number summary using the 1var stats command in our calculator. So this was in a previous video, and we can see that it's right here, the min, Q1, median, Q3, and the max. So we can then use these values to calculate the IQR, the interquartile range, and we've done that in a previous video as well. But it also allows us to calculate the fences for determining outliers. So I've got both formulas here, and you'll want to make sure that you have these formulas in your notes when you're taking the exam. So the IQR, again, is Q3 minus Q1. That's the range of the middle 50% of the data. The lower fence is Q1 minus 1.5 times the IQR. And the upper fence is Q3 plus 1.5 times the IQR. I want you to notice that the operation in the middle of those formulas is different. The lower fence is subtracting and the upper fence is adding. And that's because the lower fence will be below the first quartile and the upper fence will be above the third quartile. Okay, so the only way that these make sense is to do them. So we're going to first find the 5-number summary in our calculator. And I couldn't fit the calculator on this screen and show all the work and show the data. So I just chose the Northeast Midwest region. So here's all of our data here. So you're going to put this into L1. Once all of that is in L1, you're going to go to Stat, Calc, and you're going to choose 1var stats. And you'll see that you'll get the 5-number summary of the minimum, which would be negative 0.6, Q1, which is 2.95, the median, which is 4.9, Q3, which is 7.2, and then the max, which is 14.6. So now that we have the 5-number summary, we're going to use these values to calculate the IQR and the fences. So the IQR, again, is Q3 minus Q1. So in this case, that's 7.2 minus 2.95, which equals 4.25. Then we want to determine the fences. So remember that the lower fence is going to equal Q1 minus 1.5 times the IQR. So this will be 2.95 minus 1.5 times 4.25. And we get negative 3.425. The upper fence is going to be Q3 plus 1.5 times the IQR. So this will be 7.2 plus 1.5 times 4.25, which will give you 13.575. So what we want to see here is, are there any data values in our set that are either below the lower fence or above the upper fence? Well, this data is given to us in order, and so we can see that the minimum value here is negative 0.6, and this is not below negative 3.425. So there are no lower outliers. But if I look at the upper fence, I can see here that the maximum 14.6 is greater than 13.575. And I'm going to check the next value too, 13. 13 is not greater than 13.575, so it's not an outlier. So the only data value that's bigger than the upper fence is this 14.6, so this is our only outlier. So we are going to have an outlier at 14.6. So now we want to use this information to draw the box plot. So I've got the steps here, and this is a summary of the information that we just did on the previous page. And again, we want to remember that this 14.6 is an outlier. So we're going to create an appropriate scale, and then we're going to draw our boxes. So I noticed that the first percent change is negative, so I'm going to start with -1 here, and I'm just going to count up by ones. So I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so once I have my scale, I'm going to draw the box. The box is made up of Q1 and Q3, and then the median goes down in between the box. So looking at Q1, that's 2.95, so it's right below 3. So the left side of the box is right there. And Q3 is 7.2, so that's right above 7. And that gives me the box. And I'm going to label this just so you can see where I'm getting these numbers from. So this is Q3, which was 7.2, and this is Q1, which was 2.95. And then we can label the median, which is 4.9. That's right about there. So this is the median, which is 4.9. So that's the box. And then when we draw the lines coming out of the box, those are actually called whiskers. The full name of this is a box and whisker plot. So to draw the whiskers, the easiest one is the lower one, and that's because we don't have any outliers. So the whisker is going to end at the lowest value. So the lowest value is -0.6. So it's going to end right about there. I'm not going to write the minimum here. I'm just going to write that it's negative 0.6. It's not always the minimum because it could be an outlier. So let's do the other side and hopefully it'll make sense. We know that 14.6 is an outlier, so, and I'm a little off the page here, so I'm going to designate that with a star. So the question is, where is the whisker? A lot of people make the mistake of putting the whisker all the way up at the outlier, or they make the mistake of putting the whisker at the upper fence. But the whisker actually ends at the next data value. It's the data value that's the highest data value that's not an outlier. So it would be at 13. But it has to end at a data value. And the upper fence is not a data value. And so, and let me label this. This is 14.6, right? This is the outlier. All right, so there is the box plot. We can see in the box plot, so we can describe our distribution looking at the box plot the same way that we can with other distributions. So in looking at this box plot, we can see that it's skewed right. We can't tell whether or not it's unimodal or bimodal. That's the one thing you can't tell from a box plot. But we can see that there's an outlier at 14.6. So that's our description of the shape. The median would be the best measure for the center. And because we have that outlier, and the spread will be the IQR. I know that I've done a lot of examples where the center and the spread is the median and the IQR, but you will have other problems where you're using the mean and the standard deviation.